Zillow doing in the Antarctic? It's not like it's going to float there. So the one explanation, the logical explanation, is that that is where it lived, that's where it died, and that's where it was buried. It's the most logical explanation. So as far as I'm concerned, the Arctic and Antarctic were at least a temperate climate in the past, if not a tropical climate. And again, I will come back to that in a later lecture. This, of course, is the Grand Canyon. This is the head of Grand Canyon. It's called Marble Canyon. I bring that up because some have referred to Grand Canyon as what we refer to as a water gap. Now, water gaps are very interesting. There are dozens of them all over the world, perhaps hundreds. I've gotten to study a few of them. Grand Canyon is only one. The thing is, most people don't realize when you go to Grand Canyon, they tell you, oh, this mighty Colorado River carved out the Grand Canyon over millions and millions of years. Has anybody been there to the Grand Canyon? Oh, quite a few. Excellent. Did you hear them say that? Nobody heard them say that. Oh, one did. Okay, good. I'm not a liar. Okay, good. Glad to hear it. They'll tell you the Colorado River carved out the Grand Canyon. Nonsense. You can sort of see it a little bit here in the photo, but the lens distorts it. The Colorado River actually, or the Grand Canyon actually carves through what is known as the Colorado Uplift. It is a giant dome uplift. Now, the thing is, in order for the Colorado River to carve out the Grand Canyon, it would have had to flow uphill for 3,000 feet so it could start cutting into the Grand Canyon. Is that going to happen? Not too likely. Here's the other catch. When you take a look at the Colorado Uplift, if you're at the correct place, you can actually see the Colorado River could have gone around the uplift. The Grand Canyon is what we call a water gap. The water has mysteriously carved its way through a mountain when it could have just gone around. There was no reason for this. So let's take a look at a couple study examples. This is a water gap of the Rattlesnake Mountains in Wyoming. And if you, it's several hundred feet deep. I was told something like 2,000 feet from the top of the mountain to the bottom of the canyon. It's impressive. If you take a close look up it, you can actually see they've dammed it off. There's a hydroelectric dam. There's the access road heading up to the dam. So they've actually dammed it off. We're going to now go on the other side of the mountain, look at the dam from behind. Because this is, once again, a classic example of a water gap. There's the mountain, and there's the other side. It has been cut in half by a river going through it. Now the question arises, did the river make the canyon, or did the canyon make the river? I'll let you decide that in a minute. The water has apparently carved through this mountain. Everyone acknowledges that water did it. The thing is, in order to build that dam, we just turned, and we're now looking at the other side of the mountain. They actually had to build a cofferdam on this side in order to build the reservoir, because the water could have gone around the mountain. And in the words of a gentleman by the name of Oberlander, wrote an article a few years ago on water gaps, it was just baffling. He said, it's as if some of the water seeks obstacles to transect. It's as if the water took a turn specifically so it carved its way through a mountain. It's as if it looked for things to cut in half. It could have gone the easy way around the mountain, as any water normally would. Why would it do this? What on earth happened? You see, they're attempting to explain it from the uniformitarian perspective again. The present is the key to the past. So how do we explain this? Well, we're going to take a break, and you'll just have to come back in 10 minutes and find out, okay? And we're trying to figure out how on earth did this puny little river cut right through a mountain when all it had to do was take the easy way around. What on earth went on here? This comes back to the uniformitarian principles. The present is the key to the past. You see, it's a false presumption. The river is going through there, and sure, it's eroding the canyon out some more right now. So if the present is the key to the past, the river has always eroded it. But that doesn't work. With the Grand Canyon, the water has to go uphill 3,000 feet. Can't do it. In this case, it'd have to go uphill at least 1,000 feet when all it has to do is go around. Why did it do this? However, within the idea of a global flood, and the present not being the key to the past, it's quite simple. You see, the global flood starts with the water being above the mountains. You see where I'm going with this pretty quick, don't you? It's pretty simple. Within a global flood context, the water starts above the mountains. Now here's the thing. We were talking about these rocks. We came up with the question, you know, why were these rocks booking along at 75 miles an hour? That's even and on a 2-degree hill slope. It makes no sense. What on earth is going to make the water move at 75 miles an hour? Well, again, this comes back to a global flood. Dr. John Baumgartner and his team were performing computer modeling of a global flood. And what they've discovered, serendipitously, this was not in the original plan, this was not part of the original research, they found that the moment the water comes above the continents, it breaks down into Coriolis vortices. In other words, in the northern hemisphere, we had gigantic swirls of water moving counterclockwise, and in the southern hemisphere, we had gigantic swirls of water moving clockwise. These swirls of water were getting into the hundreds of miles an hour in the computer modeling. Well, lo and behold, now we have not only water above the land, we have water moving fast enough on a 2-degree downhill slope to pick up rocks in Idaho, transporting them 700 to 800 kilometers at 60 to 75 miles an hour, somewhere in that range. It all stacks up and makes sense within the context of a global flood. So we have not just water, but high-speed water, which, again, if you remember yesterday, the water at some point obviously went off the land. We're not underwater right now, are we? So at some point, if the water was there, it went off the land. The water is now moving at very fast speeds, and it is now going off the lands. As the scripture says, the mountains rose up out of the flood waters. And so as the mountains rise up underneath the floodwaters, with the floodwaters running off, the water is moving at very fast speed, and we get what we call sheet flow. So basically the water is moving in giant sheets. That makes planation surfaces. If it hits something like a mountain, it can plane it flat, or it will actually become channelized. And what happens here is you have a portion of the mountain or rock that's just a little softer than the rest. This water erodes it and makes a little channel. Some of that water now goes into the channel, so you actually have more flow going through the channel than in the other areas. That erodes the channel more, and so you get channelized erosion, a catastrophic sequence where it starts to cut channels straight through mountains. It cuts around them, through them, etc., until eventually today, after the water is gone, you wind up with what we call a water gap. A gap or a canyon that's been cut right through a mountain by the floodwaters, and water now flows through there today as a river or stream. Or you get what we call a wind gap, a canyon or something of the like that's been carved by water, which is dry now today. And that's the term for that, a wind gap. So the question is, did the water make the canyon, or did the canyon make the river? It's the other way around. It's not the river made the canyon made the river. The canyon was there first, the river formed after. So this is all research done by my good friend Michael Ord. Excellent articles. Do read the Creation Research Society quarterly articles on this. Very, very good stuff. Very well done. Now, to use a paleontological term, I've been flogging fossil equians. If you don't know what that means, it means beating a dead horse, okay? We've been beating a dead horse. The present can't be the key to the past. However, the uniformitarians, or present-day geologists, even the neo-catastrophists, the new catastrophists, really only use the present to judge the past when it's convenient. So the mantra that the present is the key to the past only holds true when it works in their favor. For example, okay, coming back again, I'm going to use the model at the Akron Fossils and Science Center to depict the Grand Canyon to show you what I'm going to show you next. Again, this is supposed to have taken hundreds of millions to billions of years to accumulate all this dirt and rock, okay? Now, let's take a quick look at this. A guy by the name of Dr. Derek Ager just loves to hate creationists. Sadly, he's dead now. Wrote an excellent book called The New Catastrophism. Very few books I recommend from anti-creationists, but this is one of them. He's actually trying to argue that catastrophe has played a major role throughout all of Earth's history. Okay, so that's what he's been trying to argue. Excuse me. And so in his book, he made this very interesting comment on the Grand Canyon. He said, even in the Grand Canyon of the Colorado River and the adjacent sections along the Little Colorado River, surely the finest record of geologic history anywhere on Earth, there are huge breaks. I'm going to show you just how huge. For example, here's the Grand Canyon. The Vishnu schist down at the bottom is supposed to be 1.7 billion years old, according to uniformitarian timescales, or deep time scales. The next layer up, the base limestone, is supposed to be 1.2 billion years old. So there's a time gap there of some 500 million years. There's no erosion, and apparently no sediments were left behind during this time. Now, I've done some mathematical and scientific studies. I'm on the road a lot, and my bedroom accumulates roughly 1 millimeter of sediments every year. I know this by research and first-hand experimentation and observation. This is good science. Observability, repeatability, predictability. I can predict when I get home I'm going to have 1 millimeter of dust in my bedroom, okay? So, that's a gap of 500 million years. Remember these numbers, I'm going to come back to it. So that's 500 million years gone. There's no evidence of it. Next up, we have the various Grand Canyon supergroup. Supposedly around 740 million years old. Above that, cut across by the Tapete Sandstone, 525 million years old. Again, a huge gap of 215 million years, for which there is no evidence. It's just gone. There's no evidence that that time was ever actually there. Next one up, supposedly 505 million years old, 385 million years old. Again, 120 million years, just gone. Where did it go? Next one up, 340 million years old. Next layer above that, 320 million years old. Another 20 million years, gone, vanished. Remember that number? I'm going to come back to it. Okay? We're going to play with that number just a little bit. You'll notice that's the smallest number I've given you so far of missing geologic time. We're going to come back to that number. So, right at the top, you can walk around on this plateau, this surface that's been eroded, supposedly laid down 270 million years ago. Do you not think 270 million years is going to accumulate some dirt? You think there's not going to be some erosion going on? It's easy math, okay? Real easy. We're going to take 20 million years, multiply it by 0.01 inches, you get 200,000 inches over 20 million years. Or 16,666 feet, or 3.15 miles thick of dirt. Where did it go?